we'll give you an update about vLLM. So we'll start with Zhuohan Li.
Okay, yeah. Hello, everyone. I'm Zhuohan, and I'm a PhD student at UC Berkeley, and I work on vLLM full-time. And today, I'm happy to share about some recent updates on the vLLM open source project. I would like to note here that the updates I'm sharing today are a joint effort from many people in Berkeley. And many updates are actually from the larger open source community outside of Berkeley, and many of whom are also here at the meetup today. The topic. So first, I will do a brief recap and do some bragging about vLLM, and then, Woosuk will come up to do some to say something about what we did in the past before the last meetup and this meetup. And also after that, Simon and Lily will come up to talk about our development roadmap. Okay, so let's get started. So arguably, we are in the era of LLMs. LLMs have shown remarkable capabilities in a variety of tasks, from chatting to content creation to programming. And some of these applications, such as ChatGPT and GitHub Copilot, are already changing our lives. And not surprisingly, a key part of these applications is systems that serve the LLMs using GPUs. And however, we noticed that serving LLMs is surprisingly slow and expensive. And for example, for systems before vLLM, a single GPU can only manage to serve less than one request per second for moderate size models and inputs. This means that you will need a ton of GPUs if you actually want to build a production scale services using LLMs. And indeed, the high cost of serving LLMs have been a major challenge for many in the field. And even hyperscalers like Microsoft struggle for securing enough GPUs for their LLM power services. And all these challenges motivates the vLLM project. And we started the vLLM project to build the fastest and easiest to use open source LLM inference engine. And back then, at the time we started the project, so all open source solutions were slow or very difficult to use. So we decided to make one by ourselves. And as Anthony covered just now, so while we are building up vLLM from scratch, we realized that inefficient memory management was a key performance bottleneck of LLM serving. And to address this issue, we came up with PagedAttention, a new attention algorithm that operates on blocks of KV cache. And PagedAttention enabled highly flexible memory management. And we could manage the KV cache like the virtual memory in operating systems, and achieving efficient and elegant space sharing between multiple requests. And we've observed huge performance improvements and open source vLLM to share the results. And fortunately, we get a lot of traction from the beginning, and vLLM has continued to grow with the help of community. And today, vLLM is the most popular open source project in the LLM serving area. And vLLM has very nice user and APIs. At first, it has the LLM class, which is a Python interface for offline batch inference. And we can simply create an LLM object and call generate to efficiently run inference on a batch of requests. And you can also start vLLM as a full-function OpenAI API compatible LLM server with a single command. And an OpenAI client can query the server by simply replacing the URL. And vLLM has received contributions from more than 190 contributors from all over the world. And thanks to all of the contributors. And from its release, vLLM has been adopted by many open source projects, including many Sky projects and also many companies. And most noticeably, I think vLLM has become the default serving engine of Microsoft Azure AI model catalog, and also has been featured at AMD MI300X launching event to show its inference performance. By the way, not an investment advice, but after this, I started to buy AMD stocks. And I was pretty happy in the past few weeks, and not that happy this week. That's all for my bragging. And next I will have Woosuk talk about the actual update on vLLM.
Okay. Hi everyone. I'm Woosuk. I'm a co-maintainer of vLLM. I'm maintaining it with Zhuohan, Simon, and Lily. And I'm gonna briefly talk about the major updates in the project. Okay, since the last meetup, we made pretty significant progress on the project. we've continuously added new models. We optimized latency and throughput of vLLM with different optimizations at different levels. And we added new features, including AMD GPU backend and multi-LoRa serving. Finally, we implemented CI/CD pipeline running on GPUs. Okay, thanks to the help of the community, vLLM currently supports more than 20 different model architectures, covering most of the popular LLMs in the world. Most noticeably, we have been collaborating with open source AI companies like Mistral.ai and DeepSeek.ai. They're officially contributing their models to vLLM. vLLM started to support the Mistral model from day one, and now also supports DeepSeek MOE model with an optimized fused MOE kernel. Okay, on the performance side, we have implemented a series of optimizations, including a new version of PagedAttention kernel, CUDA graph, distributed runtime optimization, and faster all-reduced kernels. Next, I will briefly go over these optimization techniques. Okay, our previous implementation of PagedAttention exploited GPU parallelism by assigning one SM for a sequence. However, this sometimes led to a significant load imbalance, just like the load imbalance between SMs, just like the figure on the left-hand side. In the new kernel, PagedAttention v2, we partition each sequence into smaller pieces and distribute them to different SMs. This is similar to flash decoding, if you're familiar with it. This optimization leads to up to 7x kernel speedup, especially for long sequences, and 15% end-to-end latency reduction for a particular case on H100. And with more and more optimizations added for GPUs, the time vLLM spent on CPU becomes more and more prominent and becomes the major performance bottleneck. In our profiling, we see that we said that the Python or PyTorch overhead takes up to 50% of overall latency, a point that GPU's execution speed is faster than the speed CPU launching the next kernels. Okay, to address this, we introduced CUDA graph into vLLM. CUDA graph records the CUDA kernels launched during the model execution and constructs a graph that can replay the recorded kernels. And this way, vLLM bypasses Python and PyTorch runtime in model execution. With CUDA graph, we achieved up to 41% latency reduction for small models like Microsoft Pi 2. Okay, another important optimization was made on our distributed runtime. Our previous system architecture involved a lot of serialization overhead in sending and receiving the inputs and outputs between the scheduler and the workers. With our new design, we completely removed the serialization overhead by converting the Python objects into GPU tensors and using LeetCode to broadcast them. This turned out to be very critical for high throughputs. We observed up to 70% throughput increase for Llama 70 billion model on 8 A100 GPUs. And our most recent optimization is the introduction of custom all-reduced kernels. Basically, LeetCode uses a ring algorithm for all-reduce, which partitions the tensor into smaller pieces and send them through multiple steps. While it performs pretty well for large tensors, the algorithm is not suitable for small tensors, which is the case for the inputs in the decoding phase. For small tensors, all-to-all style, one-shot all-reduce performs better than the ring all-reduce. In this algorithm, each GPU directly patches the tensor in other GPUs, all in parallel and in a single step. In our benchmark results, the optimization leads to up to 2.6x kernel level speedup and 20% end-to-end speedup for small batch sizes. Okay, putting these together, we've continuously optimized the throughput and latency of vLLM over the several months. In the particular setup of Llama 70 billion and 4 A100 GPUs, vLLM's throughput has increased by roughly 50%, and its latency has decreased by roughly 40%. And we are also actively optimizing the Mixtral MOE model. For example, the recent Fuse MOE kernel improved the performance quite a lot. We are working on further optimizations, so please stay tuned. Okay, on the feature side, we've added the support for AMD GPUs, multi-rollout serving, quantization, and prefix caching. Let me go over very briefly. Okay, starting from December 2023, we have added AMD GPU support for all models in vLLM. The support was contributed by the startup Embedded LLM and also AMD. We're actively collaborating with both teams to optimize vLLM's performance on AMD GPUs, especially MI300X. And in this event, we have Hai here. Could you raise your hand? Okay. Okay, yeah. Actually, yeah, he's there, but yeah, you can catch up him if you're interested in this AMD GPUs. Okay. And secondly, LoRa is an efficient way to fine-tune LLMs for different tasks. In vLLM, we integrated the techniques in SLoRa and Punica paper, so you can actually load multiple LoRa adapters on the fly during the inference, and efficiently batch together the recast to different LoRa adapters into the same input batch. This work is contributed by Anyscale with the support from SLoRa team. And yeah, quantization is the feature that has the biggest community ask. Actually, we for the several months we have refactored vLLM to support different quantization methods for all models. And through many community contributions, vLLM now supports most popular quantization methods, including GPDQ, 8WQ, Squeeze LLM, and EP8 KV cache. Okay, lastly, we added basic support for prefix caching, which allows you to cache common prefixes to different recasts. With that, the new recast can directly use the cache prefix without recomputation. For example, the example on the screen, the recast can use the cache system prompt, the yellow part, and the model only needs to compute the short user prompt at runtime. And then it can generate. You can immediately start to generate the outputs. Okay. And for now, we have a basic prefix caching support, and we're working on automatic prefix caching, which basically vLLM automatically finds opportunity to reuse the cache of the previous recast and make it transparent to the user endpoints. But due to the time constraint, there are many other improvements that I can't go through one by one. We just thank the community for these improvements. And one last thing I'd like to highlight is our new CI/CD pipeline. Now we have a nice CI/CD running on GPUs to test and benchmark every PR. We believe this will increase the reliability of vLLM. Okay, and I will hand over to Simon.
So now I'll talk a little bit about the development roadmap. We're not going to go into detail due to time constraint, but feel free to talk to any of us about any specific point of this. So let's start with 3 months ago in our first ever meetup, also in the city. This is exactly the same slide we put up about what we're going to work on about a quarter ago. And then we're happy to say we're able to basically check a majority of the boxes and all the big boxes, as well as add a lot more distributed runtime optimization and prefix caching to what we're originally planning to do. Now, this is 3 months ago to today. Let me give you an overview of the team's plan along with our collaborators for what we're going to focus on the next few months. And we're going to break it down into, again, basic improvements to the system as well as new features. So for improvements, our focus are for example, performance is definitely our top priority. And here, in particular, we're going to be focusing on performance optimization for H100 GPU, which previously, due to resource access, we're not able to access and tune vLLM on those hardware. As there are more and more H100, we believe they are going to be more and more important for serving as well. And as Mixtral and DeepSeek MOE come up, and we're going to be able to perform more optimization there. We're also thinking about scheduling optimization, in particular, how we're handling prefill and decode. So there are methods like chunked prefill, as well as prefill disaggregation. Both of these have 2 or even more papers backing behind them, improving the throughput and latency of the overall system when you have a lot of requests running at the same time. So we'll look into this with our collaborators and see how they can transparently improve the performance. We're also going to look at how do we support more methods of quantization, in particular activation quantization, to improve the performance, as well as allow you to squeeze more model, in particular improve the throughput. Lastly, modularity is a lot of sort of common ask from both the research community as well as industry community, focusing on making scheduler and memory manager, which is the core of vLLM, more extensible, so you can plug in mechanisms that will better suit your workload. And last but not least, on the improvement side, as Anthony talked about, we are eager to bring in Torch Compile to vLLM so that to sort of take advantage of the optimization made in the broad PyTorch ecosystem. Now, onto features. On sort of new support, we believe one of vLLM's strengths is the ability to run LLM on a lot of hardware. In particular, we'll continue to support, other than continue to support AMD, we're adding support from AWS Inferentia. And I believe there's a big team here from AWS focusing on this. We are working with Google TPU, as well as 2 different teams from Intel Gaudi, Habana Tensor Accelerator, as well as team working on both the Intel data center GPU, as well as CPUs. So stay tuned on sort of the support there. And across the stack, we're seeing competitive performance on different workloads compared to NVIDIA GPUs. Now, we're also thinking about adding support for multimodal. This includes models like Lava, and as you can see from GPT-4 Vision, it's a very useful model, and we believe adding support for image embeddings will help your production workload as well. We're going to support speculative decoding. This is a method that sort of improves the latency without harming the accuracy for your inference workload. And in particular, we're building a framework in collaboration with Anyscale and AWS to support a lot of different kinds of speculative decoding algorithms. So later we'll talk a little bit more. As well as Woosuk mentioned, we're adding automatic prefix caching, so you don't need to tell us, here is my system prompt, here's how long it is. Rather, vLLM will be automatically figure out the reuse of, for example, both the system prompt, your long sort of few shots prompt documents, as well as RAG documents that appears together, and such that will improve better sharing as well as improve your application latency. Finally, this is a project I'm personally very passionate about, is adding structured output support in collaboration with the best sort of library out there like Outlines and SGLang, where you are able to constrain and enforce the model to output like proper JSON according to your JSON schema, regular expression, as well as any context-free any grammar, for example, for Python code or SQL, such that you will always get legitimate output. All right, to just dive a little bit deeper with speculative decoding, Lily will talk a little bit more.
Hi, I'm Lily. So for speculative decoding, I would say since the very early stage of vLLM, we see lots of PRs about speculative decoding, but we haven't got this feature yet. So I will say this is one of the most important features, at least like from my side. And currently, we have lots of contribution from the community. Like it's a joint effort from Anyscale, like AWS, and some like independent contributors. And the goal here is to have a general design to support different flavors of speculative decoding. So speculative decoding is a way to reduce latency. So you will have draft, like we will support both like using draft models or without draft models like Medusa, Eagle, etc. And we do have a plan. So we plan to have use 9 PRs to make this feature in vLLM. So currently we already merged 2 of them. So I would say we still have like 7 PRs, including both change the design and also do some optimization. But we do need help from the contributors, right? Like we need the MQA kernels for speculative decoding to achieve a theoretical speedup, and we need efficient sampling kernels because speculative decoding do more sampling, and we also need some like verification kernel, like how do you do like tree verification. So if you are interested, let me know and let's make it work. Yeah. And lastly, we really shout out like call for contributors, reviewers, and adopters. So we are currently growing our reviewers and committers base. So please help us review the PR. So there are 100 PRs open there. So just pick anyone like you are interested in and start reviewing it. Okay. And our roadmap comes from you, the vLLM community. So don't hesitate to reach out if you are very eager for any features. Talk to us. Tell us your needs, your requirements, your use case, your workloads. And if vLLM team think it's reasonable, and let's sit together and figure out how to support it. And also, we have released our roadmap in this issue. Please take a look and let us know which one you like. And lastly, vLLM is an open source project maintained by UC Berkeley, helped by the organization adopting vLLM. So we are not VC funded, and we really need help. So in any ways, right, you can write code, review the code. You can also give us the machines, right? Because like people will complain the performance on H100 is not good. Then give us H100, right? Like give us a machine so we can fix it together, right? So any cloud credits, any hardware, or even cash, like whatever. Okay, so we need help. We are students from Berkeley. Yeah, so talk to us if you can help. Yeah, I think that's it. Yeah, this is our GitHub and anything.
Thank you. Yeah. So we'll now do a global Q&A, in which case, if you have questions that you think will benefit others as well, in particular with clarification, as well as sort of basically asking about things discussed on the slides, please ask them now. If you have questions about sort of more of settings related to your own organizations, and since you want to discuss in depth, in detail, find us right after this. Cool, we'll start. Yes.
Start with the following question. Yeah. So basically, thanks for iterating them really fast. But as a customer, we want to productionize them. We also care about how they run and what's availability. So I'm curious, every time you release a new version, what kind of testing was going on?
Yeah.
Please repeat the question while recording.
Cool. All right, so the question is about sort of the stability and how can we ensure vLLM stays as a sort of production-grade software. So first of all, I guess there's 2 parts here. One is about sort of the backward and forward compatibility, where here we ensure public APIs are sort of backward compatible, but also the main way you should interact with vLLM is through the OpenAI sort of protocol compatible server, which will make sure it is compatible with your existing workflow. On the production testing side, we run, I would call pretty extensive testing, but definitely not there yet, due to resource constraint in particular. So we'll make sure we run the test, both for the CI, we make sure we measure the correctness of the models compared against Hugging Face implementation. We scale between sort of 1 GPU as well to 8 to test like tensor parallel. We test on different kinds of NVIDIA GPUs, and sort of our collaborators from AMD help us test it on AMD. But I would say we have enough confidence that we have, for example, both the performance are there. But we need more help, more resource to test on a wider set of ranges, and that's indeed one of our focus. If you see the roadmap issue, the first item is more benchmarks and more testings. Cool, great question.
I think you also mentioned observability. I think it's something that you're going to have progressed. That's very important on that.
Right. Yeah. Thanks to our community. But actually, so the question is about observability. So I would say thanks to our community, in particular folks here, we have a lot of sort of new features added in 3.0 about point 3.0 about sort of adding Prometheus metrics, adding better logging support. That longer term you should be able that will help you monitor vLLM in production. Cool. Any question about the features or clarification?
What do you consider your closest competitor?
Cool. So interestingly, I don't think we really have a competitor as a software. Where, for example, where our definition, again here, we're trying to build the fastest, easiest to use inference and serve engine. This means alternatives include TensorRT, for example, from NVIDIA, and TGI from Hugging Face. But from our point of view, all of these are great projects that we're learning from. In particular, for example, for MOE and custom order use, we're learning a lot from TensorRT. And the competitor, and we continue to benchmark against them.
Yeah, I think, also want to add here, I think, we also mentioned this in our first meetup, is because we are an open source project, we are very happy to see any kind of new improvements and new advancements from other open source projects. Yeah, and we are happy to learn from them and study the improvements.
Yeah. Yes.
Any plan for like support for the M3 chips?
So the question is about supporting for the M3 chips. We debated about this. This is something we can potentially discuss more. Right now, vLLM focus a lot on sort of the server inference, but if there's interest and if folks are interested, potentially it would be great for both sort of local inference as well as sort of local development experience.
Yeah, I think, I want to add here, I think that's doable. And especially, I think the way we are trying to support more hardwares is to trying to find a good abstraction for these hardwares and how to make VM easier to add a new hardware. I think, after these adding other hardwares, it should also be beneficial for adding like M3. Yeah.
I think it's important to add support for the the architecture is similar to the GH200 chips from NVIDIA, this per CPU unified memory access.
Yeah.
So for the GH200 chips, you can access the CPU memory and run the fluid kernels from it. In the long run, it might end up being the thing where CPUs and GPUs are access to the same memory outlet. So it could be useful to have some sort of a unified memory.
Yeah. That's a very good point. With unified memory, it can potentially help improve our sort of performance and architecture.
Yeah. By the way, I just forgot to repeat the question. So the question just now is about support for Mac M3.
Yeah. Yes.
So you mentioned, if companies can help you. So the AI Alliance goal is to resource for complexity. Do you have a document? For your new roadmap, do you have asks? Right?
Yes.
Do you specify what you need? We can popularize it within the alliance. I mean, NVIDIA is not a member yet, so we can get some AMD, some Intel stuff. We can talk, right? So please provide a document for what you need, and we will share it with the members and see what can happen.
Yep.
I think so just to repeat for the video, it's like a comment about our roadmap to directly ask for what we need. I think right now we decided to publish our roadmap quarterly, so we actually just published our 2024 Q1 roadmap on GitHub yesterday. So please take a look, and we will add more information over there.
Yes.
And so I'm from the cloud native ecosystem, the home for Kubernetes, and there in the project we are doing our best to support different kinds of resources through this thing called dynamic resource allocation. And I'm curious about how, if those efforts are useful to you as you are building the LLM, looking at diversification of hardware, what you would need from the cloud native ecosystem, if anything at all, to support your project.
Yeah, good question. So the question is about sort of how can the cloud native world, Kubernetes, work together and to help vLLM in sort of the technical aspect. And I would say, I'm very familiar with the cloud native world. I would say vLLM right now focuses on sort of running inside a single container, a single pod on a single GPU. But down the road, and I believe many of you who are already using vLLM are doing, is to run it inside a cluster manager. And for that, we do need to see good integrations. In fact, just today I've seen somebody from KServe, which is a CNCF project, adding integration between vLLM and sort of KServe project. Thank you. Great question. Yeah. There's someone in the back. Any of you? Yeah. Nelson. Yeah.
I'm just wondering how you guys like I saw something about structured output for the VLLM. I'm just wondering how that ties.
Structured support. That's question for you.
Yes. So the question is about the structured output, and that I guess you are probably thinking about the technical part, or yes. Okay, so the technical part about structured output, we're utilizing basically how does structured output work is that during each decoding pass, after the model has proposed basically a token, where you can sort of constrain how does which token basically out of the entire token space, you'll produce a distribution of these are most likely tokens, and structured output essentially is to constrain the sample, saying like, okay, you are only allowed to sample from these legal sort of token, and such that we ensure that grammatically is correct. If you are, this is like following the approach like outlines and guidance and others, many have done that. Like JSON formers, and many have done that. Yeah.
Yeah. So I don't know how many committers do have called PI. I know this works, right? So and with the fairly committed category and the features that below, are we considering incorporating more committers and also what is the policy on that direction?
Yeah, I think definitely we are trying to add. Oh, yeah. Repeat the question. So the question is about whether we would like to add more committers and in the future, and what is the standard. I think the answer is yes, absolutely. So we definitely want to add more committers and also what's that called? Yeah, it's the one who reviews it.
Yeah, the reviewer essentially is a triaging sign in GitHub. Yes.
Yes. I think we'll definitely add it. I think it's more. Right now, because it's still only like 4 of us, and probably add with Anthony from Anyscale. We have many Anthonys. And also and we have some triage from China. Basically, they are all like mostly like top vLLM contributors. So we will reach out to them, and we can make sure they understand vLLM code base well, and they can make good PRs, and we will just promote them. It's a pretty natural process. There is not a very hard criteria right now. But I think as we grow, we will try to make this more and more clear and make it more and more, like an organic process to add more people here into the project. I think we don't have any walls here, so we would like to welcome all kinds of contributions.
Yes. One last question.
You already mentioned that the SGLang project contributed multi-LoRa support, so it looks like you guys are already like finding each other. Mm-hmm. How do you characterize the relationship between the vLLM and SGLang projects from your point of view?
So the question is about how do you characterize the relationship between SGLang and vLLM. So let me start with we're actually from the same lab, and we have the same advisor. So it's literally as the same group, and for example, SGLang and Oster sit right next to me in the lab, and so the project essentially will have a sort of a separation where SGLang focus on the grammar, the structured input and output, and optimization in the LLM application, and they have this co-design approach where you have to speak their grammar to get the benefits of their optimized runtime. Inside their runtime, they actually run on top of vLLM because vLLM offers such a great benefit of, for example, we work across different hardware, we have different optimization, we have high throughput, low latency, and works in a distributed setting. So we actually have a very clear layering here and then SGLang have basically, if you raise a blog, they can mention here are the list of specific optimization you can do if you adopt our grammar. Essentially, that goes a long way saying that where vLLM we're trying to build this sort of common backbone for optimized LLM inference, and SGLang is pushing the frontier of what can you do with this kind of LLM protocol and application. Yeah, cool. All right, so one last question there. Yeah.
I can bring up like an alternative, but a couple of the feature requests are asked here. I know are available in the Llama CPU project. I'm curious how you guys think about the Llama's ecosystem. I know it's like yes, but fun. All
great. So
get that.
Yeah.
Yeah, I think, so the question is about how do you compare vLLM with like projects like Llama CPP. I think at the beginning, we have a very, very different goals. So Llama CPP is trying to enable you to run LLMs on your laptop, but we are more like throughput oriented. We are trying to focus more on the server side and more on the basically high throughput when you like enterprise want to serve the LLM, that side of the work. But I think we are learning from each other. I believe Llama CP is also trying to add things like PagedAttention and continuous batching. And also on our side, we are, I think we are looking at, for example, the quantized kernels, very good quantized kernels from Llama CPP. I think, in general, that's what we are thinking. But and I think one thing I want to add here is basically in terms of models. So Llama CPP is like completely C++ implemented model. But right now we would like to stick with PyTorch, especially with torch.compile. I think at the very beginning we saw the overhead of PyTorch, and we thought about switching to C++. But basically when we are talking to the users and like basically through time, we find out many people actually like PyTorch because they have their own models and they want to iterate faster. So we would like to keep this benefit and stick with PyTorch and make sure use techniques like torch compile, CUDA graph, things like that to bridge the gap between Python and C++.